This video is about how to adjust the very accurate 3D printable joystick design. The goal of the adjustment is, on one hand, cover the largest possible resistance range when moving from one limit to the opposite limit, and on the other hand, to avoid dead zones where the resistance does not change. The adjustment is achieved via the mounting positions of the potentiometer axis in the joystick components. From the center position, the joystick can be moved mechanically in X and Y directions by 40 degrees each until a stop is reached. It is important to note that the Y-axis stop is only active when the joystick housing is closed. At -40 degrees, this means the lever is at the far left for X and at the very bottom for Y. At -40 degrees, a resistance value of approximately 0 ohms should be reached, and at +40 degrees, almost the maximum value should be reached. However, there should be no dead zones where the resistance does not change. Potentiometers are usually designed so that there is a dead zone at the stops, meaning that the resistance actually only changes when the movement is made by, for example, 3 to 10 degrees from the stop. This area in the video, marked in blue, should be avoided. If set up correctly, this has the advantage that the potentiometer stops are protected from excessive forces from the joystick lever. With a correctly set potentiometer circuit at the lower travel limit, the left output has a value close to 0 ohms between pins 2 and 3, but the right potentiometer has a value around 3 to 5 kilo ohms between pins 2 and 3. At the upper travel limit, the left potentiometer has a value around 3 to 5 kilo ohms between pins 2 and 3, but the right potentiometer has a value close to 0 ohms between pins 2 and 3. As can be seen in the circuit diagram of the potentiometer wiring, two potentiometers are always connected together, so that depending on the settings, a voltage divider is created that covers virtually the entire voltage range from VCC to ground. The absolute resistance of the combination is pretty unimportant here. The swing of the output voltage is much more important because this is evaluated by the analog-digital converter of the downstream Arduino Micro Pro. Here's how to adjust in detail. Adjustment of the X-axis. Step 1. Turn the axis of both X potentiometers fully counterclockwise, as viewed from the axis, until they stop. Step 2. Connect the multimeter to the middle and left pin of the potentiometer as indicated by the red arrows. Axis points onto the top. Step 3. Select the ohm range so the value around 0 ohm is displayed well. The multimeter should display a value close to 0 ohms. Step 4. While observing the ohm meter, slowly turn the axis clockwise until the value changes. Repeat this step several times to ensure no measurement errors have crept in. Step 5. Leave the position you found and mark the axis position relative to the central screw connection with a fine permanent marker. This makes it easier to reset the determined value if the axis accidentally rotates during assembly. Step 6. Screw the M4x6 screw with a 7mm head into the joystick coupling part and do not tighten it. The screw serves as a ±40 degree stop. Step 7. Insert the joystick coupling part into the joystick frame and insert the mounting bolt part as a replacement for the left axis. Secure it with an M3 screw or a pin to prevent it from rotating, so that the joystick coupling part can only rotate around its radial axis. Step 8. Turn the joystick coupling part in the joystick frame to +40 degrees. The screw is at the stop on the right. Step 9. Screw an M4x5 set screw into the lower left thread of the joystick coupling and tighten it slightly. The joystick coupling should now no longer rotate. Step 10. Carefully insert the right potentiometer into the joystick frame and joystick coupling, ensuring that the axis remains in the preset position. The central mounting nut will also be positioned during insertion. Step 11. Simultaneously tighten the potentiometer's central mounting nut using the 10 mm open end wrench. Step 12. Screw the M4x5 grub screw into the right thread and tighten it moderately so that the right potentiometer axis in the joystick coupling can no longer rotate. Step 13. Then loosen the left grub screw and remove the auxiliary axis. Step 14. Turn the joystick coupling part to -40 degrees. The screw at the stop on the left. Step 15. Now insert the left potentiometer in the same way and tighten the central mounting nut. Make sure the joystick coupling does not rotate. Step 16. Insert the left M4 grub screw and tighten it moderately so that the joystick coupling is firmly connected to both potentiometer axes. Step 17. Check whether the joystick coupling rotates easily and whether the axes have twisted. Check this with a multimeter. If the resistance value of the stops are close to zero and no dead zones have occurred, the adjustment was successful. Adjustment of the y-axis. Step 1. Turn the axis of both Y potentiometers fully counterclockwise, as viewed from the axis, until they stop. Step 2. Connect the multimeter to the middle and left pin of the potentiometer as indicated by the red arrows. The axis is pointing to the top. Step 3. Select an ohm range so the value around 0 ohm is displayed well. The multimeter should display a value close to 0 ohms. Step 4. While observing the ohmmeter, slowly turn the axis clockwise until the value changes. Repeat this step several times to ensure no measurement errors have crept in. Step number 5. Leave the position you found and mark the axis position relative to the central screw connection with a fine permanent marker. This makes it easier to reset the determined value if the axis accidentally rotates during assembly. Step 6. Insert joystick frame into joystick base and attach Y-stop to joystick frame from below. Step 7. Insert the mounting bolt to the right as a replacement axle. Secure the mounting bolt with the right M3 screw to prevent rotation, so that joystick frame can only rotate around its mounting axis. Step 8. Place the assembly flat on a level surface. Lightly press the joystick base onto the flat surface and rotate the joystick frame to -40 degrees within joystick base. You will feel a resistance. This is the Y-stop at the front. Step 9. Screw a M3x12 screw into the lower right thread of joystick frame and tighten it slightly. Make sure that the position of joystick frame does not change. After this, joystick frame should no longer rotate. Step 10. Insert the left potentiometer into the joystick base and joystick frame, ensuring that the axis remains in the preset position. The central mounting nut will also be positioned during insertion. Step 11. Tighten the potentiometer's central mounting nut at the same time using the 10 mm open end wrench. Step 12. Screw a M3x12 screw into the left thread and tighten it moderately so that the left potentiometer axis in joystick frame can no longer rotate. Step 13. Then loosen the right M3x12 screw and remove the right auxiliary axis. Step 14. Turn the joystick part Y +40 degrees with a Y stop at the rear stop while pressing joystick base onto the flat surface. Step 15. Now insert the right potentiometer in the same way and tighten the central mounting nut. Step 16. Insert the right M3 screw and tighten it moderately so that joystick frame is firmly connected to both potentiometer axes. Step 17. Check that joystick frame rotates easily and that the axes have not twisted. Verify this with a multimeter. If the resistance value at the stops are close to zero and no dead zones have occurred, the adjustment was successful.